Hello, welcome back to the playMath tutorial channel. In the last lesson, I looked at an introduction to matrices where I discussed the different types of matrices, and I think I brought up addition, subtraction and multiplication, and I kept on saying division, which we won't look at. By the way, I have not edited that video yet, so when I'm editing I will make sure I put division in red, in bold and in full caps. The reason for this, there is no such thing as division in matrices. So without taking up any more time, I will just get into some examples with addition and subtraction.
Took a swing at a wrecking ball and I prayed for my downfall.
So let's do that. If I have a matrix A, a 2 by 2 matrix A, where I have elements 2, 4, 3, and 9, matrix B with elements 3, minus 4, 11, and 6. And I'm given this question, A plus B. Now, when adding two matrices, what you do, you add corresponding elements. A matrix is normally set up like this: A, B, C, and D. So these are the position in a 2 by 2 matrix: A, B, C, and D. So when I'm adding, a next thing I should have said earlier, when adding, they must be the same order, meaning if you have a 2 by 2, you can't add a 2 by 2 to a 2 by 1, and you can't subtract it either. Both matrix here has 4 elements, making it a 2 by 2 matrix. So I can add. So let's do that. 2 plus 3 would give me a 5. 4 plus minus 4 would give me 0. A 3 plus 11 would give me 14. And 9 plus 6, 15. Right? Now say I add the same numbers and I was supposed to subtract, or the same matrices rather, and I'm supposed to subtract. 2 minus 3 minus 1, 4 minus 4, 8. And 3 minus 11, I would have negative 8. 9 minus 6, I would have positive 3. And that is what I'd get if I add these matrices. As you see, for subtraction and addition, the same thing goes. You're subtracting the corresponding element or you're adding corresponding elements. Say you add a matrix C, and C add elements minus 3, 4, negative 11, negative 6. B, or your D, let me call this matrix D, and your D has elements 3, negative 4, 11, and positive 6. Straight away we can see C is the negative of D, right? So if I add, I'd have this, a null matrix, a null 2 by 2 matrix. If I subtract C minus D, I'd have negative 6. 4 minus minus 4, I'd have positive 8. Minus 11 minus 11, I have negative 22. Minus 6 minus 6, I'd have negative 12. And this is what I would get if I subtracted this. I think that's enough examples for subtraction and addition. So let's get to some multiplication. If I have A, and in my matrix A I have A and B. These are my elements. And in my next matrix I have A, B, C, and D. And I'm supposed to multiply A times B. When multiplying, you can test if you can multiply, if it is compatible to multiply by writing out the orders of both matrices. So my first matrix has 1 row and 2 columns, right? And matrix B, my second matrix, has 2 rows and 2 columns. So that's the order. So now you look at the two inner numbers. Once both are the same, then it is compatible to multiply. How you multiply? You multiply row by column. So A times A plus B times C. Then I move to my next column. So A times B plus B times D And that is how I multiply. And note that the first matrix, the order of the first matrix is the order of your final answer. So keep that in mind. Also, A times B is different from B times A. In fact, B times A is not compatible. If I add B first, 2 times 2, right? Times 1 times 2. The 2 and the 1 are not the same, so it's not compatible. A times B is not equal to B times A. And this is for matrix. If it was numbers, normal multiplication, if you add 2x plus 3 times 7, or if you have 7 times 2x plus 3, this would be the same thing, but not for matrix. So let's do an example or two. Now say you add matrix A, and matrix A add elements 8, 1, 2, 3. Matrix F add 1, 2, 4, and 3. These are your elements. And you are supposed to multiply. So A times B. Remember, row by column. And before you can do your check. So both are 2 by 2, and you can see that the inner numbers are the same, so it is compatible to multiply. So let's do that. Row by column. So 8 times 1, let me write it out. So this is going to be 8 times 1 plus 1 times 2. Let me use the black marker for this. Plus 1 times 2. Then you move to your second column with the same row. So now we have 8 times 4 plus 1 times 3. And moving this now to our second row, and we're going back to our first column. So 2 times 1 plus 3 times 2. And for the last element, we go back to our last column using the second row again. So 2 times 4 plus 3 times 3. And that is it. Now we simplify. So 8 times 1 plus 2 would give us 10. 8 times 4 plus 3, which is 1 times 3, would give us 3, plus 8 times 4, 32, would give us 35. 2 times 1 plus 3 times 2, which is 6, would give us 8. And 2 times 4, which is 8, plus 9, 3 times 3, would give me 17. And that would be my final answer if I multiply these matrices. 3, 5, minus 2, 4, and they are multiplying it by 2, minus 1, 3, and 0. So let's do that using the first row and first column, row by column, and both are 2 by 2, so it's compatible. So 3 times 2, which is 6, plus 5 times 3, 15. Moving to the next row. 3 times minus 1, minus 3, plus 5 times 0, 0. Moving on to the next, let me put my bracket, to the next row and going back to the first column. So my first column and my second row. So minus 2 times 2 will give me minus 4, plus 4 times 3 will give me 12. Moving to my second column and still using the same row. Minus 2 times minus 1 will give me a positive 2, plus 4 times 0, giving me 0. 6 plus 15 will give me 21. Minus 3 plus 0 would give me negative 3. Minus 4 plus 12 would give me positive 8. And 2 plus 0 would give me 2. And this is what I would get if I multiplied both. Now say you have 1, 2, 3, 4, and 5, 6, and you're multiplying both. Again, this is a 2 by 2, and this is 2 rows and 1 column. We can see that they are compatible. Now, when I multiply these, I will get a column matrix. So let's do that. So again, row by column. First row, there's only 1 column. So 1 times 5 would be 5, plus 2 times 6 would be 12. Moving to our second row. 3 times 5, 15, plus 4 times 6, 24. And now when I add these, I have 17 and 39. Let me write this better. So 17 and 39. And this is what I get if I multiplied these matrices. So I hope this is helpful to someone out there, and if you want more videos like this, you can subscribe because there are more maths video coming, and I have a calculus playlist I'm working on for those who are interested in calculus. So again, thank you guys for watching. In the next video, I think I will be looking at determinants, or I will look at all three in one. So determinants, inverse, and transpose. And then I think I will leave it there for matrices, and in time to come I will use matrices to solve simultaneous equations, but I must do a simultaneous equation video before. So again, thank you guys for your support. Thank you for watching. Please share with someone you know needs help with math.
Took a swing at a wrecking ball and I prayed for my downfall.